Hello and welcome again to an episode of Behind the Scenes. And today we have a very special guest, a very good old friend of mine. Hi and welcome, Alex. How are you doing?
Hi, I'm doing acceptable.
Acceptable. Very good. I'm also doing not too bad. A little intro. All right. So what have you got for us? What are you going to show us?
Yeah, so I work at a company called Pulumi these days.
Mhm.
I'm going to show you a couple slides, not a lot of slides, just because this is the demo that I'm going to show you is adapted from a talk that I normally give. The talk is somewhat bombastically called "Cube Control is Not Enough." Can you see those slides, by the way?
I love it. Not yet. You've got to share your screen.
Oh, right. Okay. My bad.
Yep. But as soon as you
Video
share the screen, I'm
conferencing
pretty sure.
is hard.
Yeah. Should all be doing quantum
Okay.
computing and Bitcoin. Yep, perfect.
Right. Yeah.
Mhm.
Okay, cool. So the talk is called "Cube Control is Not Enough." The context for this talk, these slides are really just to tell a little bit of context about what problem we're solving and where we're coming from. So I like to begin with an observation. It is said that Kubernetes competes with Bash, and I think this statement is true, and I mean it in a very particular sense. When I say that it competes with Bash, I mean that like it wasn't that long ago that it would not have turned that many heads if you to deploy your application if the blessed path was for you to like SCP a tarball onto a server,
Yep.
SSH in, and then like unpack the tarball and like literally start your server. And the nice thing about Kubernetes generally is that it replaces most of that with like a RESTful API,
Right.
which I don't think I have to extol the virtues of to you. But I think the motivating problem that I'd like to start with is that if you think about it, Kubernetes doesn't really replace the need for Bash in the greater problem space. So a good example of this is like if you have a Helm chart and you want, you're running like a Node.js application or something, and you want to run using some hosted database like Amazon's RDS or Azure's Cosmos DB or Google's Cloud SQL, there's an extra step in there. So like let's say you have a Helm chart, you have to somehow provision the Cloud SQL or RDS database. Then you have to, once it's done, you have to parse the connection string. Then you have to munge that somehow into a Kubernetes secret, and then you have to kube control apply all of that into the Kubernetes API server.
Right.
And so the question I want to ask is there a more principled way of doing stuff like this? Stuff that doesn't fit inside the Kubernetes, the normal Kubernetes API? Is there a way to build a principled workflow that helps us do things like this, which I believe are very common? Does that kind of make sense so far?
Yep. Okay, cool.
Okay, because this is somewhat abbreviated, I'm not going to go through all of this stuff. I'm just going to skip to what is Pulumi. Okay, so Pulumi, I will give you the high-level pitch to make my CMO happy. Pulumi is basically a collection of SDKs that allows you to define and manage cloud infrastructure across multiple clouds, including AWS, GCP, Azure, and Kubernetes, using real code. And in a lot of places, I think this is a somewhat contentious issue. And for Kubernetes specifically, I'm going to argue that it is possible to keep the declarative aspects of the Kubernetes API, which I think a lot of people rightly appreciate, but also to have more principled answers to the question of how you address the broader workflow problems. Like, in other words, our goal is to say, can we replace Bash for some of these tasks? Like if I'm provisioning a database and then parsing the connection string, must I do that in Bash or Python, or can I have a principled answer with reasonable safety guarantees and this sort of thing?
Right.
I think this makes more sense when we look at code. So
yep.
I was thinking we might just dive right in. Okay, so I'm going to show you to begin the simplest possible example, which is taken directly from the Kubernetes Hello World example. There's no editorial, no opinions. It's not abstracted in any way. It's like
Alex,
literally a Kubernetes deployment that
Alex, can
deploys
I
the Nginx.
quickly interrupt
Yep,
you?
yep.
Maybe you want to switch off the video. The audio comes across a little chopped off, so if you quickly disable the video, maybe we have a better audio quality.
I clicked
All right.
the video off
Yeah,
button. Is
that's
that what you
perfect.
wanted?
That's perfect. Yeah, yeah, perfect.
Okay.
Yeah,
Cool.
much better.
Oh, okay, awesome. Let me know if it breaks up again.
Yeah. No, perfect.
So this is the Hello World example from the Kubernetes docs. The Hello World example is basically an Nginx container that is exposed to the internet using a Kubernetes service. So we're exposing port 80. If you know much about like the normal Kubernetes API, this should look pretty familiar. This is just a normal deployment, no libraries, nothing between you and the Kubernetes API, and this is just a normal Kubernetes service. Now, a thing that so the reason I show this to you is to just give you a flavor before we jump into some of the more interesting examples. A couple of things that I would point out is like because we're using this in this case is TypeScript. Because we're using TypeScript, you can hover over symbols, get documentation, get some sense of what the arguments it takes. If I start editing the text, I can do like nginx dot, and I can get all of these members.
TypeScript being what exactly? For the people out there
right,
who
okay.
might not know what TypeScript is.
yeah, that makes sense. So if I step back for a second, when I say that Pulumi is a collection of SDKs that allow you to manage infrastructure with code, what I mean is that there is a pluggable layer for implementing the SDK using multiple languages. So right now we support several languages, specifically in the Python, JavaScript, and TypeScript.
Cool.
So what I'm using now is my favorite of these, which is TypeScript, which is like a strict superset, I believe a strict superset of JavaScript that allows you to provide type hints.
Got it.
So in other words, what'll happen is if I have a program like this and it's like a .js file, the TypeScript compiler will try to infer the types of each of these variables, right? So it finds out that this is a string and this is, a Kubernetes, kates.apps.v1.beta1.deployment, et cetera, et cetera. So you can think of it for the purposes of this demo as just being a Node.js program that defines infrastructure.
Got it.
Make sense?
Yep, perfect.
Okay, cool. So the nice thing about using TypeScript, the reason why I'm using it is because of stuff like autocomplete. So like I was showing you before, I can just dot into stuff and it calls up actually the exact Kubernetes docs right at your fingertips. So this is all of these types are generated directly from the Kubernetes Open API spec. So the documentation that you see here when you hover over this stuff is the documentation you'd see if you go to the Kubernetes docs website.
But where does it know at which version we're looking? Do you have to be connected to Kubernetes API server, or how does it know which version we're looking at?
So that's a great question. The way that this works is that we aggregate several API. We are projecting all API versions of all objects into the. Okay, so what that means is that in Kubernetes the API objects are really I'm going to say stable. That's not quite the right word. They're stable in the sense that v1 beta 1 / deployment will always refer to v1 beta 1 / deployment, and v1 / deployment, like apps v1 deployment, always refers to apps v1 deployment. And so what we do is because these are persistent through time, we take all of the API objects across all of the Kubernetes versions that we support, and we just project them into objects with the documentation intact. And because the Kubernetes API, sorry, what?
No, I just said yes, I got it. And does that mean that I have to specify or select a certain version at the time I'm writing the code, at coding time, or how does that actually work from a developer perspective?
So from the perspective of the SDK, we'll see an example of what happens when we deploy it in a second. But
Okay.
from the perspective of the SDK, what you as the user do is you just write code against some API version of an object. And then when you try to deploy that to the API server, we have really nice tools that tell you whether or not that, first of all, that API object is even sensible to deploy to that server, like does it actually support it? But second of all, it'll give you really fine-grained information about how the deployment is actually going.
Got it.
Right. So in other words, to just sum up, basically you can write any API object, and any API server that can accept that API object, you can deploy to.
Right. Makes sense.
Cool. So, okay, so world's simplest example, literally just an Nginx container that is exposed to the internet with some service. What I'm going to do now is I'm going to come over to my my handy console, and I'm going to start the process of deploying it. So, Pulumi update. So Pulumi, the SDK, is driven primarily by the Pulumi command line. There's a bunch of stuff going on here. I'm running a dev version, so there's this warning here. Don't pay attention to that. But one of the nice things about the Pulumi command line is that it tells you what it's going to do before it does it. So there's this whole planning phase where it's like, I'm going to create a deployment. It's going to be called this. I'm going to create a service. It's going to be called this. And if I expand the details option, you can see that these are really just honest to God Kubernetes objects, right? So this is the deployment. Yeah. So if you pass computed values or whatever, it'll show you the result of these values. Okay. So this is like the final version of the deployment that we're going to deploy, and this is the final version of the service we're going to deploy. And so when I said earlier that this, I believe that it's possible to still maintain the valuable declarative aspects of the API. This is basically what I mean. I mean that once you pass the JSON to the constructor for the deployment object, you get like a well-formed object that you can preview, and you know, because the way the programming model is constructed, that that the planning phase is going to accurately report what is going to happen to this object. Okay, and we'll get more of an intuition for that in a second. But for now, I'm just going to deploy this. And there's a couple of things. So there's that warning again about the dev version. But there are a couple of things that I want to point out, which is that the command line actually gives you really fine-grained information about what's happening. So because we have semantic knowledge of what a deployment is, we know what phases it goes through. We know that the container is going to, we need to create a replica set. We know that we need to boot up some number of pods, and then if any of those errors out, we can report that back to the user.
Right.
So in the case of the service, it's going to try and target some number of pods. All services except type external IP target some number of pods, so it knows to look for that first. Now, because this is of type load balancer, it's waiting for us to allocate an IP address, and once it does, we can see that it has successfully completed. But the really cool thing, I think, is that if you look back at this code, there's this funny line at the end here, which is like export front end, some variable front end IP. And what export is in JavaScript, export is like the way that you export something in a JavaScript module, right? It's kind of like making something public. Yeah. And so by default, if you make a value public that is type pulumi.output of whatever, it will export that. It'll make that a stack output. So I can actually take this.
I see.
Output front end IP, and I will pipe that to pb copy. And if I go to my handy dandy browser, let's do Safari, and I paste that here, it takes me to the Nginx landing page. Okay. Now there's okay, so that's the first and most simple example, just to give you a flavor of the general workflow. What I want to show you next is a little bit more we're going to build up to this, and then we're going to end up at the example that I showed you before, or that I was talking about before, where we provision a database and automatically populate Kubernetes secrets based on that.
Right,
But
right.
so this next example is almost the same example with one important difference. So we still have a deployment that replicates the Nginx pod one time. We still have a service that exposes this to the public internet. We're still exporting the front-end IP. The main difference is that we're creating a config map out of a file. So fs.read file sync.toString that reads the file default.conf and puts it inside the config map's data.
Right.
Okay. So if I go into default.conf, this is just a vanilla Nginx config file. You don't really have to know the syntax, just that what's important to know is that this is basically setting up Nginx to forward traffic to google.com.
Yep.
Okay. So if I so what I'm going to show you first is I'm going to actually just provision this first. I have Pulumi alias to P because I type it a lot.
Absolutely. Yes, you do.
Yeah. So right. So this is pretty much the same thing as you saw before, except this time we have this additional config map. I'm going to deploy that because I want to come back to it in a second and show you what happens. Basically, what I want to do is I want to take this Nginx conf and I want to take these two places where we're configuring Nginx to proxy traffic to google.com, and I want to change those to proxy traffic instead to pulumi.io.
Okay.
Yeah. So what we're going to see in a second when I do this, when I change this file, is that when we run Pulumi update again, it will we will read the file from that, and then when we pass it through the config map, we will see what the change is, and then we will see the change ripple through to the deployment as well. And the reason I point out this example, I just want to prove that I'm not a liar by taking this deck and actually going to the browser and yeah, okay, so that's google.com.
Yeah.
Right. Okay. So now here's the thing that's kind of subtle. If you didn't know, if you update a config map in place in Kubernetes, by default, this doesn't actually trigger a deployment among the pods that reference it, right?
Yep.
So this is a common gotcha. Anybody who's deployed Kubernetes at scale has probably encountered this before. What we're going to show you now is that if I change google.com to, let's say, pulumi.com, and then I replace all, we're going to watch as Pulumi is smart enough to show us what happens when we change that. So basically what it's going to say is we're going to replace the original config map, and then we're going to update the deployment. And so what does that mean? So if I drill into the details, let's take a look. So basically what'll happen is you can see that we're going to create an entirely new config map that with the new Nginx config that points at pulumi.com instead of google.com. And this is the critical part, we're going to update the pod spec template in the deployment to point at this new config map. But the interesting thing about this is you can also see that the delete is scheduled for after the rollout is successful. So only after the deployment succeeds and the rollout is complete will we delete the old version of the config map. Does that make sense?
Yeah. And what kind of dependencies or ownerships or whatever, like what does Pulumi know about, or can you kind of teach Pulumi, this depends on that, or how does that work?
Yeah. So you definitely can. So the way that this dependency is actually modeled, that's actually a great question, is we have this config map, right? And when we get the name of the config map, so this is just nginx config.metadata.name, we have this variable nginx config name, which is of type pulumi.output.stream. Now, when we pass that to the volumes, to the deployment, so in the deployment, there's this array of volumes that we want to mount, and there's a reference to the config map. And what Pulumi will do is it will unpack this output of t string, which is the name, and it will put the computed value inside this field, config map.
Okay.
Does that make sense?
Got it. Yeah.
Right. So if we go back to the thing, we can see exactly what that is, right? So here's the config map member. Here's the old version of the config map, right? nginx-hem-t. We can see that we're going to delete that here, and we can see that the new name is the same as Well, it's the same. So here it is. So we're changing the name here. So the way that it tracks this is that you declare the dependencies using code, and then Pulumi will keep track of references to other objects for you.
Right. Cool.
Does that make sense so far?
Awesome. Yeah. Perfect.
Okay, so let's go ahead and roll this update. So we'll see, actually this should be quite a bit quicker because we just need to create a new config map. We're going to wait for the deployment to roll out. It's pretty fast, and then we deleted the original and it succeeded. So if I do front-end IPv copy, and then we go back to the browser, if it's not cached, it should point at pulumi.com, or it will point at that. Here, I'll open it in Brave instead. Okay, so it's proxied to pulumi.com. Right, okay, so that gives you, I hope this gives you sort of a flavor of what I mean when I say that it maintains the declarative aspects of the Kubernetes API, but still lets you model complex orchestrated deployments.
Right.
So this is still declarative in the sense that when we pass this data to the config map constructor, that's it, right? Like that is what the config map is going to look like, and it's something that we can inspect and reliably preview, and we can reliably reason about how the changes will ripple through the rest of the application. But it still lets you, because you have access to things like real language features like this, it still lets you do fairly interesting things and automate some of the things that would normally just be like shelling out to Python or something to munge up some YAML file. Yeah, okay. So if that makes sense, the final example that I have is the example I talked about first, which is actually quite different. This is much more complicated, even though the code doesn't look like it. Basically, what we're going to do here is we're going to create a Cosmos DB instance. Okay, so Cosmos DB is like a Mongo flavored document store put out by Azure. So I told you before, we haven't really seen many examples of it yet, but I told you before that Pulumi is actually a toolkit for general cloud infrastructure programming. We support AWS, Azure, and GCP, and this is a good example of that. So Cosmos DB is going to be, what we're going to do is, because we have some knowledge of the initialization semantics of Cosmos DB, we can take that and we can write a function called parseConstring, and we can pass the Cosmos DB, like the normal Cosmos DB connection strings to it. So if I dot into that, connection strings, you can see is just an array of string, basically. And so what we do then is this actually goes inside a Kubernetes secret. So whatever we parse out of that, we're going to put inside this Kubernetes secret, and then we're going to create a Helm chart that generates the we're going to provision the Helm chart for the classic Bitnami mean stack example. It's basically a persistent to-do application. And we can see that we're calling this secret Mongo secrets. And we're going to pass the name of Mongo secrets as a secret name into the Helm chart. And then instead of using an in-cluster installation of Mongo, it will actually just use this Cosmos DB application, or this Cosmos DB instance. Does that kind of make sense?
Yep.
Yeah. So this is like the this is actually one of my favorite examples because there's so much going on here, right? Like you're taking stuff that would normally be extremely manual, like provisioning. You think about provisioning an RDS instance and then writing some Python script once it's done to parse the connection strings and then put that into a YAML template or call like Helm with the correct values flags. With Pulumi, you get this really concise, like programming model that allows you to make really concise programs that model this in a very principled way with with this really convenient notion of completion semantics and stuff. So I would boot this up, except we're also actually booting up an AKS cluster, and that on Azure takes like forever.
Yeah, it can take a few minutes. I remember, yeah.
Yeah, it can take as many as 20 minutes. So instead of booting this up, I'll just show you the code and then point you at the examples directory in our thing. If you want to see what the Kubernetes, the AKS cluster looks like, basically it's just another file. We have like the service principal password. There's standard SDK we expose called azure.containerservice.kubernetes cluster. And that Kubernetes cluster is exported. And then the cool part about this is that we export the cluster and then what's called the Kubernetes provider. And then we can direct like this Kubernetes secret to actually be deployed onto the cluster that we provisioned.
Right.
So by default, Pulumi will just pick up whatever's in your kubeconfig. It's actually, oh, I forgot to mention this. It's an open source. The Pulumi engine and all of the code that you're looking at right now is entirely open source. So we actually depend on the official Kubernetes Go client to do things like pick up the kubeconfig file, resolve all the values, and then decide which cluster to deploy stuff onto. We also expose, what I'm showing here is that we expose more fine grain ability to decide where to put it. You can you can boot up a cluster and then in the same application say, I would like you to provision at that cluster. Yeah, so does that example kind of make sense? Even if I didn't deploy it?
Absolutely.
Okay, cool. Yeah. So let me show you, we have a GitHub repository with all of these examples. It's github.com/pulumi/examples. If you would like to take a look at this, what we're calling the mean stack example, it's Azure TS AKS-mean, and it has very detailed instructions for how to get started. The other examples are there too. The config map rollout example actually comes with GIFs, which is pretty cool.
Nice.
Yeah, but that's all I got. That's my demo.
Wow. Cool. Wow, I'm super impressed. And a lot of questions, but some of them regarding, for example, the awesome CLI, which has a lot of colors, a lot of interactivity, and a lot of other things. We got to take that offline because that's probably not so much on topic. But let's focus on the real thing, and that is Pulumi itself, and that is if I understand it correctly, if I'm putting that in layman's terms, it's kind of like you get to choose to develop in your own environment, like currently TypeScript, JavaScript, and Python, and potentially you will support other languages. Who knows? And you're essentially dealing with all these cloud provider objects, resources, APIs, so Kubernetes and all the big three players. And in a sense, it's kind of like glue code, because it actually allows you to say, provision this here, take that here, declare dependencies, update them, but not inventing a new language. You're reusing existing languages people are using, like Node.js, JavaScript, TypeScript, and Python. But while still keeping everything declarative and essentially strongly statically typed in a sense, right? You already kind of like see at the time you're coding, does that make sense? Will that, crash or whatever, rather than having to depend on, SAT or whatever to, so the SAT with E,
Yeah.
not with A, to
Yeah.
replace values or whatever. So this is really like, to me, this is super exciting, especially, that it bridges actually the gap, Kubernetes and all the potential runtime environments it has to integrate with,
Yeah.
because not everything will always run on Kubernetes, right?
Yeah. I mean, I think that's a very apt way of putting it. What we're trying to do is just to make the glue really fun to use, right? Well, I should I should not go too far down with that analogy. Yeah. So like I think what we're trying to do is not to replace Kubernetes or like or anything like this. What we're trying to do is just to make it easy to do things that seem like they should be easy. Like if you think about it, it seems like it should be easy, that you should just be able to boot up an RDS instance and then reference it in Kubernetes. Like why wouldn't like that should be an easy thing. Uh, and uh, and so I think what I think of as what we're trying to do is to be that layer between Kubernetes and all the other stuff, and also just
Right.
to make it easy to iron out problems that like little gotchas that Kubernetes has, like the fact that config maps don't trigger rollouts and
Yeah.
stuff.
Yeah. That's definitely, like, I can confirm from the Stack Overflow. I hang out on Stack Overflow a lot and trying to help people there. And this is definitely one of the top three or so things. Like, oh, I have that config map there, and why is that not picked up? Right. That's
Yeah.
definitely that.
The other thing is, like, I think when you look at other solutions in this space, like Helm or KSonnet, I think they tend to focus on like what I'm going to call the app authoring problem, where like really their goal is to make nice. Well, Helm's goal, it seems, is to like solve the installer story, but stuff like KSonnet's job is more like to make a really good app authoring experience where it's really easy to write Kubernetes YAML and stuff. And um, what I think I've learned from my experience in the ecosystem is that people will put up with pretty much any app authoring system as long as the workflow is really good. Which isn't to say that I don't like Helm or KSonnet, but I think one of the things that I'm really interested in doing is just improving the general state of the way that these workflows work, right? Like stuff like CI systems that have to stitch together a bunch of disparate parts, right? Like the only answer that really exists right now for that is like Jenkins pipelines that stitch together a bunch of like a bunch of these solutions like Helm and KSonnet and stuff like that. And so really what we're targeting is like to replace that with something that gives people the tools to reason about changes and stuff like that, and establish a provenance of what's going to happen in the update and things like this.
Right. I guess the only thing that comes close in terms of that, like, it might be a stretch, but the only thing that I can think of currently that comes close in terms of functionality, but it's neither fun nor cool, is the Open Service Broker API. And like essentially, it has essentially the same kind of like, okay, let's integrate stuff that is outside of Kubernetes with stuff that runs in Kubernetes. And as I said, it's it might be powerful, but it's certainly not fun. I can vouch for that.
So yeah, I mean, I think if you think about where Kubernetes is coming from, where it's like like I said before, Kubernetes is historically competing with Bash in the sense that you used to like literally SCP a tarball over to a server and then like SSH and start it. I think once you replace all of that with like a RESTful API, it's such a revelation that it's like, well, maybe we should replace everything with a REST API, right? Like the idea that I have like the service catalog and I can just like boot up a Cosmos DB instance or an RDS instance and then manage that from Kubernetes, I think for a lot of people is very appealing. Our answer, I think, is we started work on this, but I think roughly when it came out, and our answer was different, mostly because, well, I don't want to put words in people's mouths. I think one of the nice things about our approach is that it lets people who don't necessarily only want to run Kubernetes or who don't want to provision all of their infrastructure through Kubernetes, it gives
Right.
them an answer that is sensible.
Yeah.
And also, the other advantage of going like the language, orchestration engine approach is that you don't have to wait for the cloud vendors to like write a custom controller that allows you to
Right.
provision infrastructure behind OSBA. Um, but for the people who really just want to kube control, apply, and then receive infrastructure, I think OSBA is like a super good fit, and I think it's like super compelling, and I'll be very interested to see where the project goes.
It's funny because when you initially mentioned that Cube or Kubernetes is kind of competing with or is like Bash there, I thought you were referring to the fact that nowadays it's very common that you just curl something and then pipe it into kubectl and fly, right?
Yeah,
So it's
right.
the new the new way. And I thought you were kind of joking and meant this kind of in the good old days we would just
Yeah.
curl something and then shell fly. Okay,
Yeah.
okay, and I now got it. No, really,
Oh,
really
right.
awesome.
Oh, I should. Sorry, I should have clarified. I should clarify that next time I give this talk.
No, it's awesome.
Um,
I just when you said that, I was like, oh yeah, cool, yeah, that makes sense. But then it makes even more sense
yeah.
what you said. Awesome. Anything else you want to share around? Like you said, it's open source. People can try it out.
Yep.
Can contribute. Can people also
Yeah.
give
So
back?
so
Contribute.
right. So as an engineer, selfishly, the reason I'm going around and giving these talks is because I would like to have conversations with people in the ecosystem who have these problems. And I would like to engage with the community more with contributions and stuff like that. I am still feeling out how much of an appetite there is to perhaps contribute some of this stuff back, some of our learnings about how you build stage deployments like this. I don't know if the community is ready for that, but these are the sorts of conversations I would like to have as an engineer who's trying to work on repeatable, reproducible infrastructure. Uh, I should say that we have like a little SaaS product that you can use with the Pulumi command line. I didn't demo it. I rarely demo it for the Kubernetes people because, well, I probably should actually. But there's like a little SaaS that does things like allows you to manage organizations of people and like grant RBAC permissions and stuff like that. So if you're like an enterprise and you want to have like a cross-sectional view of what's going on in your multi-cloud deployments, that's a thing that
Right.
I think is
I,
compelling, but I also work there. Yeah,
yeah, no, it
but
makes sense. That would have been my next question, like how do you actually make money? And I think I
yeah, right.
somehow I kind of got it there. I got it. Yeah, okay,
Yeah,
cool. No,
right.
that's cool.
But for the reason why I'm giving why I was interested in talking to you about this is because I think there's a bunch of people who listen to this program who I would like to talk to about like their
Mhm.
real deployment problems. And so
Yeah.
if people have time to give it a shot and complain to me, like that would be awesome. I would love to hear about things that we don't cover. Contributions are welcome, but like code is hard, so so yeah.
All right, fair
Uh,
enough. And will you be around in Seattle for KubeCon? Will people get a chance to meet you
I
or your
will.
colleagues there? Yeah. Cool.
I believe we have a booth actually.
Oh
Yeah, we
wow.
should because we joined the CNCF, like Pulumi
Right.
Corporation joined the CNCF.
Right.
So I believe we have a booth, and if you want to come bother me in person or like
Right.
complain in person or whatever, like you can
Uh,
come do that. I'll be
and
basically booth duty all day every day.
of course, as we all do, and obviously somewhere you need to find some way to spend all the money you just raised there. So CNCF is definitely a really good place to spend that money. I get that. That makes sense. Yeah.
Oh yeah,
Cool.
yeah. Yeah, so I'm looking forward to that, especially. KubeCon is usually a pretty good audience.
Oh yeah,
People
absolutely.
people are really adventurous, right? So like, and you get like super good questions when you give a talk there. So I'm excited to be there and talk to people.
All right. Any last words? We know the page where people should start off. That's pulumi.io or
Right. Or well, so the official landing page is Pulumi. Oh, I'm not sharing my screen anymore. Yeah, the official landing page is Pulumi.com. Pulumi.io is
.com.
our docs site for the.
Okay.
If you Google Kubernetes quick start Pulumi, it'll take you to pulumi.io/quickstart/Pulumi or /Kubernetes.
Mm-hmm.
Honestly, I think so. Those are all good places to start. Since you've
Mm-hmm.
already seen a demo, I think maybe a better place to start for most of the people listening to this is the examples page that I showed on GitHub. So that's github.com/pulumi/examples.
Okay.
Um, there's a lot of Kubernetes examples. I believe I showed the exact example that that you can go to earlier
Yeah.
in the podcast,
Perfect.
but I think that's a good entry point because it gives you clear installation instructions and you can sort of play with the things that I showed you today, which is
Awesome.
would be
And
nice.
is there some Slack? I'm pretty sure Slack or IRC or any place where people can test you on a daily basis,
Yeah.
24/7.
So my job is to get pestered every day.
Yeah.
If you go to Pulumi.com, there's like a link in the top right that points at the
Mm-hmm.
Pulumi community Slack.
Cool.
The entire company's there. You can bother any of us. People are generally super responsive. So.
And so what you're saying is we should bother and pest your boss rather than yourself because you have to code,
Well,
right?
I do have to code, but I also have to figure out what to do next. So
Okay.
the more people that bother me, the easier it is to decide what things are useful to do.
Makes sense. Makes sense.
Yeah.
Okay, cool. Perfect. All right. So thank you so much, Alex. And
Sure.
well, I hope we see us at the KubeCon in Seattle, and hope many other folks come and say, hey, I want this feature or that feature, and how can we take it to the next
Yeah,
level?
that'd be great.
Cool. Thank you
All
so
right. Thanks
much.
for having me. Mhm.
Yes.